In this video, we're going to be going over domain and range of a function. And this is our part 3 video inside of Math 20-1. So in our previous video, we looked at domain and range of a function. And in this video, what we're going to do is some practice questions for domain, range, and also functions. So let's get started with this video. So starting off, we're going to do some practice on functions. So fill in the missing words. So for the question number 1, a function is a really special type of such that every x value is connected to only one y value. And the answer for this is a relation. So a function is a special type of relation that where every single x value is connected to only one y value. For our second question, the collection of all the inputs to a function is called the blank. And the answer for this is domain. So all the inputs to a function is called the domain. For question number 3, the collection of all the outputs of a function is called and the answer is range. So all the outputs would be a range inside of a function. And finally, for the last question, the vertical line test says that any given vertical line should only cross the graph, and the answer is once. So if the vertical line test goes through once, then that means that is a function. So this was our first question for practice on functions. So now continuing, what is the domain for the following function? And here is the function that we have, and what would the domain be for this? So this is really simple. All we do is look at the input side, so the x side, and then the domain would basically just be 5, 6, and 4. So the possible answers that we have is 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, or all real numbers. And the answer is obviously A, 4, 5, 6, and that is the domain for this function here. So continuing, determine if the following is a function. So the question that we get is y is equal to -1. So is this a function or not? So let's see if it is or not. So let's just plot this onto an actual graph, and we can see that once we plot it, it looks like a horizontal line. So we have a graph here, and if we put y is equal to -1, then we have a horizontal line. So this is actually a function, and this is because a horizontal line, every single x value has a value of -1. So every single x value is connected to only one output, which is -1. So that means this is a function. Moving on to our next question, determine if this one is a function, yes or no. And for this one, we have x is equal to 1. So if we were to plot this onto the graph again, let's see how it looked like. So we can see that if x is equal to 1, it goes straight through where x is equal to 1. And this is obviously not a function. So if we look at this here, if we do the vertical line test, we can see that for one of the following places, which is x is equal to 1, we can see that there is multiple different y outputs. So since there's multiple different y values for one x, that means that this is not a function. And moving on, determine if this is a function, yes or no. So we have a plot in this case, and this is how the plot looks like. So would this be a function, yes or no? And this one is a function, and this is because this graph passes the vertical line test, since at any single point for x, there's only one point that is on the y. So like if we were to create a vertical line right here, we can see that there's only one point. If we were to make one over here, there'd only be one point. So this passes the vertical line test, which means that it is a function. Moving on to this one, determine if this one's a function, yes or no. And for this plot, it looks like this. And for this one, this is not a function. And this graph is not a function because it does not pass the vertical line test, since we can draw a vertical line and it intersects more than one point. So if we were to create a vertical line right through here, then we can see that it hits 2 points. So since it hits 2 points, that means it's not a function. So for this next question, the following relation is not a function. However, if a pair of inputs and outputs were eliminated, it could form a new relation that is a function. So which pair should be eliminated so that it actually becomes a function? And this is the mapping that we have. So we have 7, which is contributed to 4 and 5. We have 6 to 6, 8 to 5, and 9 to 6. So the pair that should be related, so the pair that should be removed is obviously one of these that are connected from 7. So if we look at the answers, the possible answers, we have 7 to 5, we have 8 to 5, 9 to 6, or D to 6. So in order to make this a function, all we gotta do is just remove 7 to 5. So if we remove 7 to 5, then that means every single one of the inputs have exactly one output. So the answer for this question is A, 7 to 5. That's what we need to remove in order for this pair to become a function. And that summarizes all the practice questions for domain, range, and function. So thank you so much for watching from Try to Be Useful, and we'll see you in our next math video.